Hey everyone, it's Dr. Bianchi here. I hope that you're all hanging in there and doing all right. I wanted to make a quick video because I have a couple of emails from students asking about one of the questions on the Chapter 9 practice problems. It's the last question asking you to compute a confidence interval, which is another measure of effect size. We've already talked about Cohen's d. We've already talked about the amount of variance explained, or R squared, both very common measures of effect size. Our third measure of effect size is called a confidence interval, and it's really simple to compute. I'm going to show you how to solve that problem here in this video. Let me go ahead and pull the question up. Okay, so here we are. This is the question from the practice problems last week. We can compute confidence intervals for any of our t-tests. And a confidence interval basically tells us with a certain degree of confidence where the true population mean might lie. In most of our research, we use samples to test out our inferences about the population. The whole point of using the t-test approach is because we lack some of the information about the population. We're using our sample as a proxy to predict what would happen to the entire population had they been in the study. So let's look at this question here. We have a sample of 16 scores, and the mean on some kind of outcome or assessment is equal to 58. And the sum of squares associated with this data is 960. Okay, I'll show you why that's important here in a moment. Use this info to construct a 90% confidence interval for the true population mean for mu. Okay, so we know that this sample has an average of 58, but where can we expect the population average to lie? With 90% confidence, what is the window that that population mean could be? Is it between 50 and 65? Is it between 55 and 61? Confidence interval is going to give us that range of values that tells us where we can be somewhat confident the population mean would lie. Okay, so let me go ahead here and walk you through the solution of this. I'm going to stop the share. This up here is the formula for computing a confidence interval, and I'm just going to move my computer a little bit closer so that you can see that. Okay, the confidence interval is equal to the mean that you're given in the problem, okay, plus or minus the standard error times the critical t-value that comes from the t-table. Okay, let me go ahead and just walk through this problem here. Okay, our confidence interval is equal to the mean. Okay, in this case, it's the mean of 58. Okay, plus or minus. Okay, we have to do plus and minus. Okay, to get the lower and the upper number. The standard error of the mean times the critical t-value in the table that's associated with the degrees of freedom for that problem. So if we have 16 participants in this study, we're going to be using the t-value that's linked up with 15 degrees of freedom. Remember, degrees of freedom is equal to n minus 1. Okay, so now if you look at this problem, okay, our confidence interval is going to be equal to 58 plus n minus, okay, we need to get the standard error of the mean, and we also need to find the t-value. Okay, let's go ahead really quickly and just find that t-value. I am pulling up my t-table here. And this is where the confidence level at the top of the t-table comes in handy. Okay, depending on the problem, you're going to have to locate the level of confidence you want. In this case, we want to compute a 90% confidence interval. And we're going to scroll down to 15 degrees of freedom. Okay, the t-value here is 1.753. Okay, that's where we get the t-value. Okay, we find our level of confidence up top. Okay, and then we find the t-value that's linked up with the appropriate degrees of freedom. Okay, 1.753. Okay, so this value here is going to be 1.753. Now, what's missing? We need the standard error, and you might remember that we have to go back and calculate that using the formula. Okay, so I'm going to erase this right now, and go through calculating the standard error. Now you'll remember the standard error of the mean is equal to the variance over the degrees of, over the sample size, okay? But we have a problem because the actual question doesn't give us the variance. This is where we have to go back to formulas we used in the beginning of class, and we can use the sum of squares in order to get the variance. Okay, so let me go ahead and just show you that. We know that sample variance, okay, this is all the way back to the first couple of weeks of class, okay, is equal to sum of squares over degrees of freedom. This is all on the first page of the formula sheet, our basic formulas that we started with. Well, that's going to be equal to 960 over 15. If we do that math, we end up with 64. Okay, our variance is equal to 64. We needed to calculate the standard error to get the confidence interval. That requires us to know the variance. The problem did not give us the variance, but it gave us the sum of squares, which we can use to compute the variance, as shown here on the board. Okay, we have 64 as our variance. Okay, let's go ahead and get the standard error of the mean. SM is equal to the square root of the variance, 64, over the sample size, 16. That ends up being the square root of 4. We end up with a standard error of 2. Okay, that is the critical missing piece for our confidence interval. Okay, let me go ahead and get my confidence interval now. Okay. So our confidence interval is equal to 58, right, the mean, plus and also then minus the critical t-value of 1.753 times 2, the standard error. Okay, so if I do 58 plus 1.753 times 2, I'm going to get the upper boundary, which ends up being 61.506. And then if I do 58 minus 1.753 times 2, I get the lower boundary of 54.495. Okay, we are 90% confident that the true population mean falls somewhere between 54 and change and 61 and change. We have 90% confidence in that range of values. Okay, so that's how we compute our confidence interval. We use the critical value from the t-table that is linked up with the right degrees of freedom. We look at the level of confidence that we're going for. We match those up, and then we use the sample mean as well as the sample standard error in order to get this range of values. Okay, that's how you compute a confidence interval for a one sample t-test. Any questions, let me know. Hopefully this video has clarified that question. You can see more about confidence intervals in the textbook and also in my lecture video for chapter 9. Okay, you should be moving into chapter 10 this week, looking at the 2-sample independent sample t-test. Again, we'll be calculating a t-statistic, and we can back that up with measures of effect size like Cohen's d, the amount of variance explained, and also confidence intervals. Okay, I will be back next week with some calculations for the 2-sample t-test. Okay, I hope everyone has a great rest of the day. Have a great weekend, and I am here if you need help or have any questions. I promise you that the second part of the stats project is coming very soon. Okay, so stay tuned for that.